February 14th, 1943, 15:45 hours, 18,000 feet above Guadalcanal. First Lieutenant Kenneth Walsh of VMF 124 pushed his F4U Corsair into a steep climbing turn, the massive Pratt & Whitney R2800 engine hauling the 7-ton fighter upward, with authority that still amazed him after 2 weeks flying the type. Below and behind, 4 Mitsubishi A6M fighters were attempting pursuit, their pilots executing the kind of graceful, swooping turns that had terrorized Allied pilots for over a year. Walsh watched them fall away, unable to match his climb rate, their lightweight construction and modest horsepower suddenly revealed as fatal limitations rather than tactical advantages. What those Japanese pilots didn't know, what their intelligence services had failed to grasp despite months of encounters, was that they were witnessing the arrival of an aircraft that would systematically destroy the myth of zero invincibility. The Corsair, with its distinctive inverted gull wing and enormous propeller, represented not just incremental improvement over previous American fighters, but a fundamental reimagining of what carrier-based fighters could achieve. Within 18 months, Corsair pilots would claim kill ratios exceeding 10-1 against the aircraft that had dominated Pacific skies since Pearl Harbor. The transformation from zero superiority to Corsair dominance reveals truths about aerial warfare that Japan never fully understood until too late. The story begins not with the Corsair's combat debut, but with the Zero's reign of terror. When Japanese Navy pilots flew the A6M into combat over China in 1940, they possessed what seemed like the perfect fighter. Weighing just 3,700 pounds empty, powered by a 940 horsepower Nakajima Sakai engine, the Zero could outmaneuver anything in the sky. Its climb rate was exceptional, its range unprecedented for a fighter, over 1,900 miles with drop tanks. Its armament of two 20mm cannon and two 7.7mm machine guns provided adequate firepower. Japanese designers had achieved these capabilities through ruthless weight reduction, no armor protection for pilot or fuel tanks, minimal structural strength beyond what flight loads required, construction techniques that emphasized lightness over durability. This design philosophy worked brilliantly in 1940 and 1941. Over China, Zeros massacred Soviet-built fighters flown by Chinese pilots. At Pearl Harbor, Zero pilots flew circles around obsolete American aircraft that even got airborne. Through the first 6 months of Pacific War, the Zero established air superiority wherever Japanese forces advanced. Allied pilots who survived encounters reported an enemy fighter that could turn inside anything, climb away from any threat, and remain airborne for hours. The psychological impact was devastating. Allied pilots developed zero phobia, convinced they flew obsolete aircraft against a technically superior enemy. The reality was more complex. The Zero was optimized for specific combat conditions that existed in 1940. Long-range bomber escort over China required exceptional endurance and climb performance. Dogfighting with poorly trained opponents rewarded maneuverability over all else. But these same design choices created vulnerabilities that American engineers and tacticians would systematically exploit. The Zero's lightweight construction made it fragile. A few hits from heavy machine guns could cause catastrophic structural failure. Its lack of armor meant pilot casualties were extremely high when Americans learned to hit them. Most critically, its modest power limited top speed and especially dive performance, the latter becoming decisive as American pilots developed tactics exploiting these weaknesses. Japanese test pilots and engineers understood these limitations from the Zero's inception. They had made conscious decisions to sacrifice protection and dive speed for range and maneuverability. In 1940, when the primary mission was bomber escort over China against poorly equipped opponents, these trade-offs seemed reasonable. The Zeros that decimated Chinese resistance validated the design choices. But warfare evolves, and the Pacific War environment of 1943 bore little resemblance to the China conflict of 1940. The Japanese aviation establishment proved tragically slow to recognize that their premier fighter's design philosophy had become obsolete. The F4U Corsair emerged from different design philosophy entirely. In 1938, the US Navy issued a specification for a carrier-based fighter emphasizing speed, climb rate, and armament. Chancefort's design team, led by Rex Beisel, responded with a proposal so audacious it seemed impractical. They would make the most powerful engine available, the 2,000 horsepower Pratt and Whitney R2800 Double Wasp, with the largest propeller that could be fitted to a single-engine fighter, 13 feet 4 inches in diameter. To provide propeller ground clearance without impossibly long landing gear, they designed an inverted gull wing that allowed shorter gear while maintaining clearance. The result looked strange, almost ungainly, but the performance projections were spectacular. The engineering challenges of this design were enormous. The R2800 engine was the largest and most powerful radial engine in production, an 18-cylinder monster that weighed over 2,300 pounds and required sophisticated cooling and oil systems. The enormous propeller needed to absorb 2,000 horsepower without excessive vibration or structural failure. The inverted gull wing, while solving the propeller clearance problem, created complex aerodynamic and structural challenges. The wing fuselage junction needed to be immensely strong to handle combat loads while maintaining smooth airflow. Every major system on the aircraft pushed contemporary technology to its limits. The XF4U prototype first flew on May 29, 1940, and immediately demonstrated exceptional capabilities. In October 1940, test pilot Lyman Bullard coaxed the prototype to 405 miles per hour, making it the first American fighter to exceed 400 miles per hour. The Navy ordered production, but translating the prototype's performance into an operational carrier aircraft proved extraordinarily difficult. The Corsair's high landing speed, long nose that blocked forward visibility during approach, and tendency to bounce on carrier decks created problems that delayed carrier qualification for over 2 years. These carrier suitability problems stem directly from the design choices that produced the Corsair's exceptional performance. The enormous engine and propeller placed the center of gravity far forward, requiring a long nose that inevitably blocked pilot visibility during the tail-down approach attitude required for carrier landings. The powerful engine and large propeller created torque effects that caused the aircraft to roll left during landing approach, requiring constant right aileron input that fatigued pilots and complicated the already difficult carrier approach. The high wing loading, a consequence of mounting 2,000 horsepower on a relatively small airframe, meant high landing speeds that left little margin for error on carrier decks. The Navy decided to deploy initial Corsair squadrons to land bases where these characteristics mattered less. Marine squadrons operating from Guadalcanal, New Georgia, and other captured islands would introduce the Corsair to combat. This decision, initially seen as compromise accepting the Corsair's limitations, proved strategically brilliant. Land-based Corsairs could carry heavier fuel loads and ordnance than carrier operations permitted. They could operate from rough coral runways that would damage more delicate aircraft. Most importantly, marine pilots could focus entirely on air-to-air combat and ground attack without the distraction of carrier operations during their critical learning period. The decision also reflected the Marine Corps' desperate need for a fighter that could compete with the Zero on favourable terms. Marine aviators flying F4F Wildcats from Guadalcanal had been fighting outnumbered against Zeros for months. The Wildcat, though rugged and reliable, was outclassed in speed and climb by the Zero. Marine pilots had learned to survive through tactics that emphasized their aircraft's strengths, but they were losing pilots and aircraft at rates that couldn't be sustained. The Corsair represented hope that Marines could not just survive but dominate in aerial combat. VMF-124, the first Marine Corsair squadron, arrived at Guadalcanal on February 12, 1943. The squadron's pilots had trained extensively in the Corsair's capabilities and, critically, in tactics specifically designed to exploit its strengths against the Zero. These tactics, developed through analysis of Zero combat performance and testing against captured examples, emphasized speed and altitude advantage over dogfighting. Corsair pilots were instructed never to attempt turning combat with Zeros. Instead, they would use superior speed to control engagement geometry, attacking from altitude in high-speed diving passes, then using superior climb performance to regain altitude advantage. The training that VMF-124 pilots received before deploying represented a significant evolution in American fighter pilot preparation. Earlier in the war, Fighter pilots had learned basic flying skills and some gunnery, then deployed to operational squadrons where they learned tactics through experience or died. By early 1943, American training had become systematized. Pilots practiced tactics against other aircraft simulating enemy capabilities. They flew extensive gunnery missions against towed targets until deflection shooting became instinctive. They studied intelligence reports about enemy tactics and capabilities. They learned energy management, the art of trading altitude for speed and speed for altitude to control combat geometry. The first major test came on February 14th when VMF 124 encountered Zeros escorting bombers attacking Allied shipping near Guadalcanal. The engagement demonstrated both Corsair capabilities and pilot adaptation requirements. Several Marines, reverting to instinctive turning combat, found themselves in trouble when Zeros easily outturned them. But pilots who maintained discipline, using speed and climb to control the engagement, achieved easy victories. First, Lieutenant Walsh shot down 3 Zeros, pioneering techniques that would become standard Corsair tactics. Walsh's combat report from that engagement reveals the tactical principles that would guide Corsair operations throughout the war. He described maintaining altitude advantage, diving at high speed to attack, firing brief accurate bursts from his 650 caliber guns, then using the speed gained in the dive to zoom climb back to altitude. Japanese fighters attempting to follow his climb found themselves helpless, bleeding airspeed as they climbed, becoming easy targets for follow-up attacks. Walsh noted that the Zero pilots seemed confused by tactics that avoided turning combat, as if they had never encountered an opponent who refused to dogfight. The engagement revealed that the Corsair's advantages were overwhelming when properly employed. Top speed of 417 miles per hour versus the Zero's 335 miles per hour meant Corsairs could engage or disengage at will. Rate of climb of 2,890 feet per minute at sea level versus approximately 2,400 for the Zero provided altitude advantage that Zero pilots couldn't counter. Most devastatingly, the Corsair's 650 caliber Browning machine guns, firing armor-piercing incendiary ammunition, could destroy Zeros with brief bursts. The lightweight Zero, built without armor or self-sealing fuel tanks, disintegrated under fire that would merely damage more robust aircraft. The psychological impact of these early encounters cannot be overstated. Marine pilots who had been fighting defensively for months, using every trick to survive against superior performing Zeros, suddenly found themselves flying a fighter that dominated every engagement. The confidence boost was enormous. Pilots who had approached combat with trepidation now sought out Japanese fighters, knowing they possessed overwhelming advantages. This psychological shift from defensive survival to offensive hunting transformed marine fighter operations in the Solomons. Japanese pilots initially dismissed the Corsair as just another American fighter, perhaps faster but surely inferior in the dogfighting that Japanese doctrine emphasized. This misconception cost them heavily. Zeros attempting to maneuver against Corsairs in turning combat found that while they could indeed turn inside the American fighters, the Corsairs simply disengaged, climbing away to altitude where Zeros couldn't follow effectively. Japanese pilots who tried to pursue climbing Corsairs watched helplessly as the American fighters pulled away, often climbing vertically in demonstrations of power that no Zero could match. The intelligence failure that prevented Japanese forces from understanding the Corsair threat reflected larger problems in Japanese military culture. Japanese doctrine emphasized offensive action and fighting spirit over objective analysis. When reports arrived describing a new American fighter with exceptional performance, staff officers often dismissed these accounts as exaggeration or excuses for failure. The institutional belief that Japanese fighters were inherently superior, that Japanese pilot spirit would overcome material disadvantages, prevented honest assessment of the Corsair threat until the kill ratios became undeniable. By April 1943, multiple Marine Corsair squadrons were operating from Solomon's bases, and the kill ratio trends became undeniable. VMF 124 claimed 68 Japanese aircraft destroyed by mid-May against 4 Corsairs lost to air combat. VMF 213 and VMF 214 reported similar results. Other squadrons transitioning to Corsairs achieved comparable performance. The Corsairs' technical advantages, combined with tactics that exploited those advantages, were systematically destroying Japanese air groups. Japanese commanders recognized the threat and began warning pilots about the bent-wing American fighter, but warnings couldn't overcome the fundamental performance disparity. The scale of Japanese pilot losses in the Solomons campaign was staggering and unsustainable. Japan began the Pacific War with approximately 3,500 trained naval aviators, the product of a pre-war training system that emphasized quality over quantity. Through 1942, attrition reduced this force while training produced replacements at a rate barely maintaining strength. The Solomons air battles of 1943, with Corsairs inflicting disproportionate losses, accelerated the bleeding of experienced pilots. By mid-1943, Japanese Navy air groups contained increasing percentages of poorly trained replacements who stood no chance against experienced Marine Corsair pilots. The Corsair's firepower advantage deserves particular emphasis. 650 caliber machine guns, each firing 800 rounds per minute, created a cone of destruction that few aircraft could survive. The guns were harmonized to converge at 1,000 feet, creating a beaten zone where all 6 gun streams intersected. At that range, a 1-second burst put approximately 80 rounds into a target area the size of a Zero's fuselage. The armor-piercing incendiary rounds, each weighing half an ounce and travelling at 2,900 feet per second, punched through the Zero's thin aluminum skin and ignited fuel or ammunition. The mechanical reliability of these guns was itself a significant advantage. The Browning 50 caliber machine gun was one of the most reliable automatic weapons ever developed. Properly maintained, these guns could fire thousands of rounds without malfunction. The synchronized mechanism that prevented rounds from striking the propeller arc worked with remarkable reliability. Pilots could depend on their guns firing when triggers were pressed, a confidence that affected combat effectiveness significantly. Some Japanese aircraft, by contrast, suffered from unreliable weapons that jammed or failed at critical moments. Japanese pilots who survived Corsair attacks described the experience as terrifying. The heavy machine guns made a distinctive sound, deeper and more menacing than the lighter weapons on Japanese fighters. When Corsair pilots opened fire, the 6 guns created a visible stream of tracers that seemed impossible to evade. Zeros hit by this fire didn't just sustain damage, they came apart. Wings separated, fuselages broke in half, fires erupted instantly. The psychological impact on Japanese pilots who witnessed their comrades destroyed so completely was profound and cumulative. Some Japanese aviators developed a fatalism, believing that encounters with Corsairs meant death regardless of their actions. The technical specifications tell part of the story, but the human element mattered equally. American pilot training by 1943 emphasized gunnery, tactics, and aircraft systems knowledge far beyond what Japanese training provided. The average American fighter pilot arriving in the Pacific in 1943 had accumulated over 300 hours of flight time before entering combat, including extensive gunnery training against towed targets and realistic tactical exercises. Japanese pilots, facing pilot shortages from steady attrition, were entering combat with as little as 100 hours total time and minimal gunnery training due to ammunition shortages. This training disparity multiplied the technical advantages American aircraft provided. A well-trained Corsair pilot understood his aircraft's capabilities intimately. He knew the optimal climb speed for maximum rate of climb, approximately 155 miles per hour. He knew the aircraft could dive to 550 miles per hour without structural failure, though control forces became extremely heavy. He knew the best altitude for performance was between 15,000 and 25,000 feet, where the supercharged R2800 engine produced maximum power. He practiced deflection shooting until leading targets became instinctive. He flew formation until maintaining position required minimal attention, leaving mental capacity for tactical awareness. American training also emphasized aircraft systems management in ways Japanese training did not. Corsair pilots learned to manage their engine's complex systems, including the 2-stage supercharger, intercooler, and oil temperature controls. They understood fuel management, knowing which tanks to use when to maintain proper center of gravity. They learned emergency procedures for various failures. This systems knowledge meant American pilots could focus on tactics during combat, rather than struggling with their aircraft's operation. Japanese Zero pilots, even experienced ones, rarely received such comprehensive training. They learned to fly the Zero, mastered basic aerobatics and gunnery, then deployed to operational units where they learned through experience or died. The survivors became formidable, using the Zero's maneuverability and their hard-won experience to remain dangerous opponents. But these elite pilots represented a decreasing percentage of Japanese fighter strength as attrition ground down the veteran cadre that had dominated early Pacific air combat. By late 1943, the average Japanese fighter pilot was less experienced than his American opponent, a reversal of the situation that existed at Pearl Harbor. The battle for the Solomon Islands through 1943 became a massive air combat laboratory, where Corsair tactics evolved through operational experience. Marine squadrons based at Guadalcanal, Munda and Torquemada flew daily missions against Japanese bases at Rabaul, Bougainville and other strongholds. These missions, typically involving fighter sweeps, bomber escort or ground attack, provided continuous combat against Japanese fighters defending their bases or attacking American positions. The steady accumulation of combat experience allowed successful tactics to be refined, while unsuccessful approaches were abandoned. Major Gregory Boyington, commanding VMF 214, the famous Black Sheep Squadron, pioneered aggressive Corsair employment that maximized the aircraft's strengths. Boyington, a veteran of the Flying Tigers who had flown against Japanese aircraft in China, understood Zero capabilities intimately. He emphasized altitude advantage and high-speed tactics, while prohibiting his pilots from attempting dogfights. His squadron's tactics became models throughout marine aviation. Boyington's personal success, ultimately claiming 28 victories, demonstrated that the Corsair in skilled hands was a war-winning weapon. Boyington's approach was elegantly simple but required discipline to execute. Corsair flights would climb to 25,000 or 30,000 feet before entering areas where Japanese fighters operated. From this altitude, Boyington could see enemy aircraft below and choose when and how to engage. When Zeros or other Japanese fighters were spotted, the Corsairs would dive at high speed, building energy that translated to both velocity and potential altitude. The attacking Corsairs would blast through enemy formations, firing brief accurate bursts, then use their superior speed and climb performance to zoom back to altitude. Japanese fighters attempting to follow the climbing Corsairs found themselves helpless, unable to match the American climb rate, perfect targets for follow-up attacks. This boom and zoom tactic, as it became known, proved devastatingly effective. It maximized every Corsair advantage while negating Zero's strengths. Speed meant Corsairs controlled engagement timing. Altitude provided energy advantage that could be converted to speed or climb as needed. The heavy .50 caliber armament meant even brief firing opportunities produced kills. The robust Corsair construction meant that even if Zeros scored hits during the initial diving attack, the Corsair usually survived damage that would destroy more fragile aircraft. The tactic required discipline, particularly resisting the temptation to pursue Japanese fighters into turning combat, but pilots who maintained discipline consistently achieved multiple kills without losses. The statistics from this period are remarkable. Between February 1943 and January 1944, Marine Corsair squadrons in the Solomons claimed over 500 Japanese aircraft destroyed against fewer than 30 Corsairs lost to air combat. The kill ratio approached 20-1, unprecedented in air warfare history. Even accounting for overclaiming, which affected all sides in World War II air combat, the real ratio was probably 10-1 or better. The Zero, which had dominated Pacific skies for 18 months, was being systematically defeated by an American fighter designed specifically to exploit its weaknesses. Individual Corsair pilots compiled victory tallies that would have seemed impossible earlier in the war. Lieutenant Kenneth Walsh, who pioneered Corsair tactics in the February 14th engagement, finished the war with 21 victories, all against Japanese aircraft in the Solomons. Major Robert Hansen of VMF 215 shot down 25 Japanese aircraft in a 6-week period before being killed in a ground attack mission. Captain Donald Aldrich of VMF 215 claimed 20 victories. These aces and dozens of others demonstrated that the Corsair provided a platform from which skilled pilots could achieve consistent success against Japanese opposition. Japanese response to the Corsair threat evolved slowly and incompletely. Some Japanese pilots adapted tactics, avoiding combat with Corsairs when possible and focusing on slower, more vulnerable aircraft. Japanese commanders issued directives instructing pilots not to engage Corsairs in the Americans' preferred high-altitude diving attacks. But Japanese doctrine, training, and aircraft design all emphasized dogfighting and maneuver combat. Changing this institutional focus while fighting a desperate war proved impossible. Japan did develop improved fighter designs, including the Kawanishi N1K1 George and later Zero variants with improved engines, but these aircraft arrived in small numbers and often suffered from poor reliability or insufficient pilot training. The A6M 50 variant, introduced in late 1943, attempted to address some of the type's shortcomings. It featured a more powerful engine, stronger wings allowing higher diving speeds, and improved armor protection. But these improvements came too late and didn't go far enough. The A6M5 remained inferior to the Corsair in speed, firepower, and structural strength. The modest improvements merely narrowed the performance gaps slightly without eliminating American advantages. Japanese pilots flying the improved Zero still found themselves outclassed by Corsairs flown by well-trained American pilots employing energy tactics. The carrier qualification saga that delayed Corsair naval deployment actually benefited the type's combat introduction. By the time Navy fighter squadrons began operating Corsairs from carriers in late 1944, Marine pilots had refined tactics and identified necessary aircraft modifications. The Navy Corsairs that deployed aboard carriers in 1945 benefited from raised pilot seats improving visibility, stronger tail hooks preventing landing gear failure, and stall warning systems alerting pilots to dangerous flight conditions. Most importantly, Navy pilots inherited 2 years of tactical development by their Marine counterparts. They entered carrier operations knowing exactly how to employ the Corsair for maximum effectiveness. The modifications that made carrier operations practical were extensive, but didn't compromise the Corsair's performance advantages. Engineers raised the pilot's seat 7 inches and installed a frameless bubble canopy that improved visibility during carrier approaches. They added stall strips on the leading edge of the port wing that caused that wing to stall slightly before the starboard wing, eliminating the violent snap roll that had killed several pilots. They strengthened the tail hook and its attachment structure, solving the bouncing problems that had plagued early carrier trials. These changes, combined with improved pilot training and carrier operations, transformed the Corsair from a carrier problem child into an effective carrier fighter. The Battle of the Philippine Sea in June 1944, the largest carrier battle of the Pacific War, demonstrated Corsair capabilities in fleet defense. Navy Hellcats did most of the fighting in what became known as the Great Marianas Turkey Shoot, but Marine Corsairs operating from recently captured Marianas bases contributed to the Japanese aerial defeat. The engagement saw Japanese Navy aviation effectively destroyed, losing over 600 aircraft and most of their remaining experienced pilots. While Corsairs weren't the primary American fighter in this battle, their presence in Marine land-based squadrons provided additional air defense that Japanese strike forces couldn't overcome. The battle illustrated how American advantages had compounded by mid-1944. Japanese pilots flying against American forces faced not just superior aircraft, but superior radar detection, fighter direction that vectored interceptors to optimal positions, and numerical superiority that allowed multiple fighters to engage each target. Japanese strike aircraft, attempting to penetrate these defenses to attack American carriers, were decimated before reaching their targets. The few that survived to attack found American ships protected by massive anti-aircraft barrages that downed additional attackers. The kill ratio in this battle exceeded 30-1, a level of dominance that effectively ended Japanese naval aviation as an effective force. By late 1944, Corsair deployment expanded dramatically. Navy squadrons operating from Essex-class carriers finally took the F4U to sea in large numbers. These carrier-based Corsairs performed fighter sweeps over Japanese bases, combat air patrol protecting the fleet, and ground attack missions supporting amphibious landings. The Corsair's exceptional range, combat radius of 1,000 miles with drop tanks, proved valuable for long-range strikes against Japanese bases as American forces advanced toward Japan. The ability to reach targets that other fighters couldn't, combined with the Corsair's combat effectiveness once it arrived, made it invaluable for the island-hopping campaign. The Corsair's evolution into a multi-role fighter bomber represented another advantage over the Zero. While the Zero could carry small bombs for kamikaze attacks, it was never an effective strike aircraft. The Corsair, by contrast, could carry 4,000 pounds of bombs or 8 5-inch rockets while retaining its air combat capabilities. This versatility meant Corsair squadrons could perform ground attack missions, then immediately engage defending fighters on equal or superior terms. Japanese defenders faced the dismal reality that the same aircraft bombing their positions could destroy their fighters if they attempted interception. The Okinawa campaign from April through June 1945 showcased the Corsair in its element. Marine and Navy Corsair squadrons flew from captured airfields and carriers, providing air cover for the massive amphibious operation while fending off kamikaze attacks. The kamikaze threat, suicide aircraft deliberately crashing into ships, required fighter coverage that could remain on station for hours while maintaining combat capability. The Corsair's combination of firepower, performance and endurance made it ideal for this mission. Pilots could patrol for hours, then still possess the performance and armament to destroy attacking aircraft. Corsair pilots defending the fleet at Okinawa encountered the ultimate expression of Japanese desperation. Aircraft used as guided missiles. The kamikaze required different tactics than conventional air combat. Intercepting pilots needed to destroy the attacker far from the fleet, as damaged aircraft could still reach and damage ships. The Corsair's 650 caliber guns proved perfect for this mission, delivering enough firepower to destroy or disable kamikaze or aircraft at ranges exceeding 1,000 yards. Many kamikaze were flaming wrecks before they closed within effective anti-aircraft range of the fleet. The psychological impact of facing suicide attacks was severe, but Corsair pilots had the tools and training to defeat this threat consistently. The kamikaze attacks represented Japan's admission that conventional air combat against American fighters was futile. Rather than engage in air-to-air combat they couldn't win, Japanese commanders directed pilots to ignore enemy fighters and focus solely on reaching and crashing into ships. This tactic, born of desperation, achieved some success but couldn't alter the war's trajectory. American fighter pilots, flying Corsairs and other advanced fighters destroyed kamikaze at appalling rates. The few that penetrated fighter screens faced intense anti-aircraft fire that downed most remaining attackers. The kamikaze caused casualties and damage, but they couldn't stop American advance. The final months of Pacific War saw Corsairs conducting fighter sweeps over the Japanese home islands, shooting down defending fighters and strafing ground targets. These missions demonstrated that the Corsair had evolved from a fighter designed primarily for air combat into a genuine multi-role aircraft. The same Corsair that could destroy Japanese fighters in air combat could carry 4,000 pounds of bombs or 8 rockets for ground attack. This versatility, combined with the type's exceptional performance, made the Corsair the most capable fighter bomber in American service by war's end. Missions over Japan revealed how thoroughly Japanese air defenses had been degraded. American fighters roamed over Japanese cities and military bases with relative impunity, shooting down the few defending fighters that attempted interception and destroying ground targets at will. The Japanese Army and Navy air forces, which had fought desperately to defend Okinawa, were shadows of their former selves by summer 1945. Fuel shortages grounded most aircraft. Pilot training had essentially ceased. The remaining pilots were mostly inexperienced teenagers flying obsolete aircraft. Against well-trained American pilots and Corsairs, they stood no chance. The kill ratio statistics from the entire Pacific War are extraordinary. Corsair pilots claimed over 2,100 Japanese aircraft destroyed in air combat, while losing 189 Corsairs to enemy aircraft. The resulting 11-to-1 kill ratio stands as one of the most lopsided in aviation history. Even after accounting for inevitable overclaiming by victorious pilots, a phenomenon that affected all combatants, the real ratio was probably 7 or 8-to-1. No other American fighter type, not even the excellent P-51 Mustang or F-6F Hellcat, achieved comparable results against Japanese opposition. Understanding why requires examining the factors that produced this dominance. The technical performance advantages were substantial but not overwhelming in isolation. The Corsair was faster than the Zero but not impossibly faster. Its climb rate was better but not double. The real advantage came from combining multiple performance edges that, when properly exploited through tactical discipline, created a cumulative advantage that Zero pilots couldn't overcome. Each individual advantage might be marginal, but together they created a package that dominated every aspect of air combat. Speed advantage meant Corsair pilots controlled engagement geometry. They decided when to fight and when to disengage. Japanese fighters couldn't force combat on unwilling Corsairs because they simply couldn't catch them in level flight. This forced Japanese pilots into defensive mindsets, reacting to American initiative rather than imposing their own plans. The psychological disadvantage of always reacting, never controlling, undermined even experienced Japanese pilots. Combat became a series of encounters where Americans attacked on their terms, while Japanese pilots struggled to survive. Climb performance translated to altitude advantage. And altitude was potential energy that could be converted to speed or sustained maneuvers. Corsairs operating 5,000 feet above Zeros possessed energy that could become a 100 miles per hour speed advantage in a dive or fuel multiple high-speed zoom climbs. Japanese pilots watching Corsairs dive, attack, and climb back to altitude understood intellectually what was happening but couldn't counter it. The aircraft simply lacked the performance to match these tactics. The frustration of understanding the tactical situation but being unable to respond must have been psychologically devastating. The firepower disparity was perhaps most important. The 650 caliber Browning machine guns fired approximately 4,800 rounds per minute combined. At 1,000 feet range, the convergence point where all 6 streams intersected, this created a cone of destruction that few aircraft could survive. The Zero, with its lightweight construction and lack of armor, was particularly vulnerable. A half-second burst that hit could destroy a Zero. A full second of aimed fire virtually guaranteed destruction. Japanese fighters couldn't withstand this level of firepower, and no amount of maneuvering could reliably evade it once Corsairs entered firing range. But technical advantages alone don't explain the kill ratio. Pilot quality mattered enormously. American pilot training by 1944 was producing aviators with 400 to 500 hours of flight time before combat, extensively trained in gunnery, tactics, and aircraft systems. Japanese pilot training, degraded by instructor casualties and fuel shortages, was producing pilots with 100 to 150 hours total time and minimal gunnery training. An average American fighter pilot in 1944 was more skilled than an average Japanese pilot, independent of aircraft quality. This training gap widened as the war progressed, reaching catastrophic proportions for Japan by 1945. The institutional system supporting pilots mattered as much as individual skill. American squadrons had excellent maintenance that kept aircraft operational. They had abundant spare parts that allowed rapid repairs. They had sufficient fuel and ammunition for extensive training even during combat operations. They had intelligence services that briefed pilots on enemy capabilities and tactics. They had rest and rotation policies that prevented complete exhaustion. Japanese squadrons, by contrast, struggled with inadequate maintenance, parts shortages, fuel scarcity, limited intelligence, and personnel policies that kept pilots in combat until they were killed. The Corsair also benefited from American industrial and logistical capacity. Damaged Corsairs were repaired rapidly, using plentiful spare parts shipped from American factories. Corsair engines received regular overhauls, maintaining performance at design specifications. Fuel and ammunition were always available, allowing extensive training and combat operations. Japanese forces, by contrast, struggled with parts shortages, inadequate maintenance, and fuel scarcity that limited training and operations. A Zero and Corsair might have similar performance when both were new, but after months of combat operations with different maintenance standards, the Corsair would be performing near specifications while the Zero's performance degraded significantly. Combat experience also played a role. By 1944, many American Corsair pilots had flown dozens of combat missions, accumulating experience that sharpened their skills and judgment. They had survived mistakes and learned from them. They had seen what worked and what didn't. This experience base, combined with superior training and better aircraft, created a gulf in combat effectiveness that Japanese pilots couldn't bridge. Even Japan's remaining elite pilots, the survivors of China and early Pacific combat, found themselves outclassed by American pilots with better training, more experience, and far superior aircraft. The myths surrounding both aircraft deserve examination. The Zero was never the superweapon that Allied pilots feared in 1942. It was a well-designed fighter, optimized for specific missions, with critical weaknesses that became fatal once opponents understood and exploited them. Japanese designers had made deliberate trade-offs, accepting vulnerability to gain range and maneuverability. In 1940, fighting poorly trained opponents in obsolete aircraft over China, these trade-offs seemed brilliant. In 1944, fighting well-trained Americans in advanced fighters like the Corsair, the same trade-offs were fatal. The Corsair was never the uncontrollable beast that carrier qualification troubles suggested. It was a powerful, high-performance fighter that required proper training and disciplined operation. Pilots who respected its characteristics and flew within its capabilities found it remarkably effective. Pilots who treated it casually or attempted to dogfight more maneuverable opponents learned hard lessons. The aircraft rewarded skill and punished sloppiness, characteristics that actually improved overall pilot quality by forcing aviators to master their aircraft thoroughly before attempting combat operations. The bent-wing bird's distinctive appearance, initially mocked by some pilots as ungainly, became iconic. The inverted gull wing that enabled the massive propeller gave the Corsair an aggressive, predatory look that matched its combat performance. Japanese pilots learned to fear that distinctive silhouette, knowing it represented speed, firepower, and tactical sophistication they couldn't match. The very appearance of Corsairs overhead could cause Japanese formations to break up, pilots seeking escape rather than engaging an opponent they knew dominated them. This psychological dominance, built on months of one-sided combat, represented an advantage as valuable as any technical specification. The final victory statistics for the Corsair are impressive beyond the air-to-air kill ratio. Corsairs flew 64,051 combat sorties in the Pacific. They dropped 15,621 tons of bombs on Japanese targets. They fired 12,500 rockets at enemy positions. They claimed destruction of Japanese aircraft, ground installations, shipping, and other targets worth incalculable value to the Japanese war effort. The Corsair was not just a fighter, it became a complete weapon system that contributed to Japanese defeat in multiple ways simultaneously. Post-war analysis by Japanese aviation experts and pilots confirmed what combat statistics suggested. The Corsair represented a fundamental challenge that Japanese aviation never solved. Its combination of performance, firepower, and pilot quality, employed through tactics that maximized American advantages while negating Japanese strengths, created a dominance that Japan couldn't counter with available resources. Some Japanese pilots suggested that only abandoning the Zero entirely in favor of more heavily armed and armored fighters might have helped, but such aircraft would have sacrificed the range that Japanese strategy required. The legacy of Corsair versus Zero combat extends beyond immediate tactical lessons. It demonstrated that industrial capacity, pilot training quality, and tactical innovation mattered as much as individual aircraft performance. Japan designed an excellent fighter for the conditions of 1940 but failed to evolve that design or supporting systems adequately for 1943 and beyond. America designed a fighter that emphasized performance over ease of operation, then provided the training and tactical doctrine necessary to exploit that performance. The institutional system supporting the aircraft mattered as much as the aircraft themselves. The Corsair continued serving post-war, flying in Korea where it again proved its versatility in ground attack and air combat roles. Some foreign air forces operated Corsairs into the 1960s, testament to the design's fundamental soundness, but its finest hour came in the Pacific War, where it and its pilots broke Japanese air power and proved that superior technology, properly employed, could achieve decisive victory. The kill ratios weren't accidents or statistical anomalies. They were the inevitable result of better aircraft, better training, better tactics, and better logistics applied systematically over years of combat. The bent-wing bird that carrier qualification troubles nearly relegated to secondary roles instead became the most successful carrier-based fighter of World War II. Its distinctive appearance, initially questioned, became symbolic of American naval aviation. Its performance characteristics, purchased through complex engineering that required enormous propellers and unusual wing geometry, proved exactly what Pacific air combat required. The Corsair's story validates the principle that, accepting unusual or difficult design choices to achieve superior performance can pay enormous dividends when those performance advantages align with tactical requirements. For the Zero, the story is one of initial success undermined by failure to evolve. The aircraft that terrorized Allied pilots in 1942 was essentially unchanged in 1945, while American fighters advanced dramatically. Japanese industry, under strain from strategic bombing and resource shortages, couldn't modernize the Zero adequately. Japanese training systems, depleted by instructor losses and fuel shortages, couldn't maintain pilot quality. Japanese tactical doctrine, embedded in institutional culture that emphasized maneuver combat and offensive spirit, couldn't adapt to defensive fighting against numerically superior opponents. The Zero's defeat was systemic, not merely technical. The final truth is stark. The Corsair didn't just beat the Zero, it achieved such complete dominance that by 1945, Japanese pilots avoided combat with Corsairs when possible. The aircraft and tactics that emerged from Marine squadrons in the Solomons in 1943 evolved into a weapons system that Japan had no answer for. The kill ratios reflected not luck or isolated incidents, but systematic superiority across every dimension of air combat. Speed, firepower, and training combined with tactical discipline produced results that changed Pacific air warfare fundamentally and irreversibly. The bent-wing bird had earned its place in aviation history by systematically destroying the myth of Zero invincibility and proving that properly applied technology could achieve victory that courage alone could never accomplish.